So in this video, I'm going to talk about another most important advanced SAT quadratic function problem. And the question is, there are quadratic function y is equal to 1/4 times x minus 4 squares graphed on the coordinate plane. Let's assume that the point B will exist when we draw a parallel line through the x-axis direction from the point A, which is y-intercept. Solve for the possibility, this is our ultimate question, solve for the possibility of a segment AB where it passes through the linear function. And what is the linear function? Y is equal to 1/2 times x. So the linear function is 1/2 x plus a when the a value from a possibility from a regular octagon dies. So in order to approach this question, we basically have first things to know in order to solve this question. First thing that we're going to talk about is types and the definition of the intercepts on the coordinate plane. The first thing that we're going to talk about, or the thing that we need to know in order to solve for this question, we're going to be what is the intercepts, which is going to be our first thing that we're going to talk about. You can see, and as we have talked about intercepts in a lot of videos, it is same thing. It is same thing with the points, but it's not just a points. It is points on. It's a point on the coordinate plane. And if you think about what the coordinate plane is, if you don't know exactly about it, coordinate plane is a formation that we can think about it as the points on the point or the plane that contains x and the y-axis. And as we can see, through the x and y-axis, that means the point on the coordinate plane can be either in the x or the y-axis. Therefore, there will be two situations for the intercepts. The first case, we're going to be what is the x-intercept. The first case of our intercept, the types we call it, the first type of our x-intercept of the intercept, we're going to be what is the x-intercept, which is our first case of our intercept. Well, we know the definition of the intercept is there is a point on the x or y-axis. X-intercept means the point is on the x-axis, which means if you convert this into a coordinate, it will going to be x, 0. And if you explain exactly or specifically about this, we can say that when the input of our value that we notated as the x exists, and the only reason why we notated as the x as a variable, not a specific value, is because we know that the x value or the y value were going to be a variable, which means the changes or varies depends on times. So we can just notate it as the variable. Now if you think about the output of our function that I'm pointing out, the output of our function, which we call it as the y, or sometimes f of x, depends on times, they're exactly same. The output of our function always should equal 0 when the input of our function x exists. This is what the x-intercept will going to be. Now, let's think about the second case of our intercept, which we're going to be the y-intercept. The y-intercept is exactly the same kind of concept with the x-intercept, except the coordinate or a point is on the y-axis. So the coordinate of our y-intercept will going to be 0, y. So if we explain specifically about this, we know that x value should always be the input value, and the y-intercept will going to be when the input x value always equals 0. Our output of our function, which we're going to call it as the y or f of x, will going to be the output, and it will exist. And the reason why we notate it as the y or f of x sometimes is exactly same kind of concept with the x-intercept. We know that x and the y value, they are all variables, which means they changes depends on times. So x and y are variables, and we can't notate variables as specific values. So we thought about it. We can notate it as the x, our input of our function, y, the output of the function. And this was our first solution, or the ways, or the things that we need to know in order to approach this question, types, as well as the definition of the intercepts on coordinate plane. And if you review what we did here, and as we can see our definition of the intercepts, we're going to be the points. It is the same thing with the points on the coordinate plane. If you don't know what the coordinate plane is same thing with a plane that is notated with or be made or consist of the x and y axis. Therefore, the intercepts, there will be gonna be two cases where the point is on the either x, so we're gonna be x-intercept, or y-intercept. This was the first solution to approach this question. Now, it's time for us to think about the second solution, or the thing that we need to know in order to approach this question, which we're going to be properties, as well as the definition of the octenary dices. Now, I think as we have talked through this, we can think about it also, the third solution. Now we're going to talk about the octenary dice, but before we think about it, we need to think about what is the dice. Then we can think about the octenary. The definition of our dice is, it is a small cube. It is a small cube. If you think about what the cube is, it is a six-sided, we can say rectangle. But it's a rectangle that has 6 sides, and it is a 3D. Which means we can't really think about this 3D coordinate plane. So it's a 6-sided rectangle, which we call it as a cube, and the 6 sides should all of them should be equal size. And first of all, with each side having a different number, and the different number of spots on it ranging from 1 to 6. We can think about something from here. From the 1 to 6, that means it always starts from 1 to 6. And one of the properties of the cube is it has no negative value, which means there is no number there that is less than 0, and no 0. So we can simply think about this through an equation. The number, which we notated as the n, in the dice should always be greater than 0. So if you think about what the octenary dice is, it is exactly the same kind of concept with just a dice, except it is a 8-sided regular dice. And if you think about the definition of the regular in the geometry world, we can say that regular is same thing with the equal, which means the octenary dice has the 8-sided equal side dice. So as we can see from its property of the dice, octenary dice has the 8-sided regular dice, and the chances from each one will going to be numbers. So the numbers that we can see, the chances from the octenary dice will going to be 1 to 8. Think about the information from our information that the A value is from a regular, it's a possibility from a regular octenary dice. So the possibilities of A value, which is from it is a possibility from an octenary dice, will occur beside the numbers 1 to 8. Which means the A value, the value of the A can be 1 over 8 the 1 over 8 will going to be the possibilities. So the 1 over 8 will going to be possibilities that the A contained, which means the A value is from the octernary dice, which has the A size, and the A value can only be one number or value. And from the 1 over 1 to 8, there are total 8 numbers, and one of them will going to be 1 over 8. So our possibilities from our A value, which will occur from the octernary dice, the A side is equal regular dice, will be 1 over 8. That we did here is also a properties of definition of the octernary dice, as well as the possibilities of A, which is a variable from the form of the regular octernary dice. And we have our last things that we need to think about in order to approach this question, which will going to be all about the quadratic and the linear functions. Think about just a function, not a quadratic or a linear function. It is a stuff that requires a specific input. And with that specific input, since we inputted a specific value to our original equation that the function has, we're going to generate a specific output of our function. And for that output, so for our input value, we notate it as the x value. And for the output value, which will gonna be generated by our input from our equation the function contains, we'll notate it as the y value simply. And or the f of x. This is what the input and the output generates the function is. So there are basically two kinds of functions that we usually talk about in the function problem. The first one will going to be the linear function, which is the most basic part of the function. And let's think about properties and the definitions of linear functions. So the basic format of the linear function will going to be y is equal to mx plus b. And from here, we know that if we notated already expressed linear function on the coordinate plane, it will going to be a straight line that satisfies our equations from the function. And if you think about what does each variable does in the linear function, y should always be the output. And same thing with x should always be the input of our function. And with that input and output, there will gonna be a specific equation for that. Let's think about what is m, which is a coefficient of our variable term. The m will going to be slope of our function, which means how it shows how steep the function is. And according to its sign of its slope, the direction that the function is going will be different. And let's think about what is b. The b will going to be a y-intercept, and we know what the y-intercept is, as we have talked about it with the first solutions, or the first way that we need to know in order to approach these questions. If we convert y-intercept into a specific coordinate, it will going to be 0, comma y, so we'll review it. 0 will going to be our input value, which will going to be the x value, and when the x value equal to 0, our output of the function, which we call it as the y over f of x depends on times, will exist, and we notate it as just a y value because it is a variable. And the variable's definition is it is a thing that changes depends on times, and x and the y value will going to be the variable on our quadratic or linear function. Let's think about what is a quadratic function. There are basically three general types of the quadratic functions forms. And for that information, it will going to be a vertex form, basically standard form. So the three types of our quadratic function form will going to be standard form, binomial form, as well as the vertex form. And we're going to talk about its forms, what is it optimized for, and its properties that shows what the quadratic function will look like on the coordinate plane. What we think about is, first let's think about it's more specific about the quadratic function. As we can see from its name, quadratic, the variable has the second degree power term, which is same thing with the square. So basically, the basic formula we're going to be y is equal to ax squared. And obviously we can see that the highest degree power term in the quadratic function we're going to be x squared. It is a highest degree power term. And according to the x value, which we're going to be our input, it makes the quadratic function. And if you notate this in our coordinate plane, which is formed by the x and y axis, it will going to be a specific parabola. It will going to be a specific parabola if you convert a quadratic function to a graph, because of some reasons, and we're going to talk about it through each forms of quadratic function. And as we can see, quadratic function is different with just a linear function. Firstly, let's think about what is a standard form in our quadratic function. Its basic form will going to be y is equal to ax squared plus bx plus c. And as we can see, standard form is the most basic format in our quadratic function. And if you think about what it is optimized for, it is optimized for the calculations. And the calculation involves in the, for example, involves in the y-intercepts, usually. And this is what the standard form is. It is a form that is optimized for just a calculation for solving for a variable or the constants. But the bad things about the standard form is we know that the vertex is the most important thing when it comes to graphing a parabola on the coordinate plane, and it is formed by x, y. Every single coordinate is formed by x, y. But bad thing about the standard form is we can't solve for our vertex, which means we won't be able to solve for our graph. We can't draw a graph with the standard form. In order to draw a graph from a standard form, we need to convert this into some specific formulas. Or we need to convert this into specific format of our quadratic function to solve for our vertex and solve for a graph on our coordinate plane. Now let's think about the second one, which will going to be our binomial form. The binomial form, the format is y is equal to a times x minus p squared plus q, as we have talked in a lot of videos. And as we can see, the binomial form is optimized for solving for the x-intercepts. And if you review what the x-intercept is, if we convert this into some specific coordinate on the coordinate plane, it will going to be x, 0, which means when our input value exists, our output value should always be equal to 0. And the reason is because the binomial form is formed by the x-intercept. The x value or the q value, not the x minus plus q, it will going to be y is equal to a times x minus p times x minus z. This is an actual binomial form. The reason is because we know that just a positive p and just a positive z value will going to be our x-intercepts. And as we can see, binomial form is formed by a x-intercepts. That's why it is optimized for solving for the x-intercepts. And one thing that is convenient about the binomial form is the vertex, which is the most important tool to solve for our quadratic functions graph, which is x, y. We don't have to convert binomial form into some specific formats or apply our formulas. The reason is because, according to the property of our binomial form, our x value input of our vertex, it is same thing with the average. Recall it as the arithmetic means of x-intercepts. which means we know that the x value, which is the input of our vertex, it is same thing with the average, which means in order to solve for x value, all we have to do is add our 2x-intercepts and divide it by 2. That is same thing with solving for the average, which is known as the arithmetic mean. And if we solve it, we'll be able to solve for x, which will going to be our input value. And all you have to do in order to solve for a y value to finish our or complete our vertex is to simply input our values to our original equation or the function that it contains. Then we'll be able to solve for our vertex and graph it. Now let's think about the last one, which is one of the most important thing on our quadratic functions form, the vertex form. Vertex form. Vertex form, the format will going to be y is equal to a times x minus p squared plus q. And as we can see from its name, it is obviously optimized for solving for our vertex, which is the most important thing in our quadratic function. The reason is because we know that the vertex is formed by every single coordinate on our coordinate plane. Also including the vertex, we're going to be x comma y, where input and output exist. And for the vertex form, our p value, which is next to the x value, the p value will going to be the input of our vertex, which is same thing with the x value, and our q value, which is a constant value, will gonna be exactly the same thing with the output, the y value of our quadratic function. And that is the one of the most important thing about the vertex form that we can solve. And our vertex form is y is equal to a times ax minus p squared plus q. So we basically talked about the last ways, or the last thing that we need to think about in order to solve for our equation, all about the quadratic and the linear function. Now let's apply everything that we talked about into our actual problem. Our ultimate question in this case is to solve our y is equal to negative 1 over 2x plus a, the a, which is a constant value, which means it never changes. So let's write our linear function down that we're trying to solve, which will going to be y is equal to negative 1 over 2x plus a. And we're trying to solve for the value of the a, and our a value is obviously going to be a constant, it never changes. And we can think about the property of our linear function here. We're trying to make this linear function passes through the point A. So it will look something like this. And the point B. So it will look something like this. And we need to pay attention to each lines that passes through the point A and B. They are parallel. So what does it mean by the parallel lines? And which means if we connect a straight line, each one should be 90 degrees. That's what the parallel will look like. And what does it mean by the parallel in our linear function? Well, the parallel line, we're going to be defined the m value, the slope, should be equal, which means the slope of our quadratic function should always be exactly same in order to be parallel, but a different, so it should be a different y-intercept. This is what the parallel in our linear function means. The slope, which we call it as the m value, should always be the equal, but the different y-intercept. What is our y-intercept? It is a constant, it never changes. We notate it as the b. In this case, the y-intercept was going to be a value. So we're trying to solve for the a values possibilities. So we are trying to solve for the a value possibility that makes these two lines passes through the point AB, and we're trying to solve the every single lines that is beside point B, A, and B. So that means the m value, our slope, should always be equal. To solve for it, we need to think about what is the coordinate of A and B. The coordinate of A, right over here, it will going to be a y-intercept. So it will going to be a y-intercept, which means the x value is 0 and our y value exists. So it will going to be x comma y, and the x value 0 and our y value exists. But there is no way to solve for our output, our y value of our function, without any information. But there is information. We know that the x value is the input and our y value is output. All you have to do is find the specific function or the equation. So all you have to do is solve for the specific function or the equation that satisfy our y-intercept, which means the function should passes through our point A. And there is a function. The function, which is a quadratic function, y is equal to 1 over 4 times x minus 4 squared, passes through that point A. So let's write it down. Y is equal to 1 over 4 times x minus 4 squared. As we can see, it is a quadratic function. It is a quadratic function, which means when you convert this into a graph on the coordinate plane, this will going to be a parabola. So all you have to do is input our x value back to our original function at 0 and solve for our output of our function, which will going to be our y value. So if we actually try this, we're going to get y is equal to 1 over 4. Instead of x value, we input 0 minus 4 squared. All you have to do in order to solve for a y value is simplify our expressions. So if we do it, we're going to get y value is equal to 1 over 4 times negative 4 squared. According to the order of operation, if we square it, even though it's negative, it will turn into a positive value, because we are multiplying exactly the same kind of things. Negative 4 times negative 4, it will going to be negative times negative will turn to positive. It will going to get positive 16. So this whole expression will going to be y is equal to 1 over 4 times 16. So we'll be able to solve for our output of our function y. We're going to be positive 4. So our full coordinate of our a value will going to be when our x value is equal to 0. Our y value will going to be 4. This is clearly a y-intercept. Let's think about what is our b value. Well, b value is exactly apparently from our question is it has exactly the same kind of y coordinate, which is 4, but the different x-intercept, x coordinate, because it is not a intercept. It is not a intercept, which means the coordinate x, our input, and our coordinate y, which is 4 in this case, exist together in the coordinate. So as we can see, even though our 4 is the output of our function, in this case we are converting this into a input. And now we're thinking about the x value, which was our input, as the output to solve for our x value. So all you have to do is input our output value, which is 4, back to our original function. And our original function was, if you remind yourself, it was y is equal to 1 over 4 times x minus 4 squared. If we input our input output as the input to our y value as 4, it will be equal to 1 over 4 times x minus 4 squared. And in order to isolate our terms, all you have to do is multiply 4 to the both sides. And we'll be able to remove our coefficient and we're gonna get 16 is equal to x minus 4 squared, which is another way x minus 4 times x minus 4. There will be two cases of our x value. The x value can be either 8 or 0. The reason is because if we input 8 to our x value to the both of our equation, we're gonna get positive 4 times positive 4, 16. But even though we input 0 to our x value, we're going to get negative 4 times negative 4, which is also going to be a positive 16. So all we have to do in this case is prove this visually if this is right on our coordinate plane through our graph. As we can see, our b values x coordinate is on the positive side. So our x coordinate of our b value is on the positive side. As we can see, the x value can't be 0. In this case, x value should be 8. So our total b value, we're going to be 8, 4. So in this case, let's write our linear function y is equal to negative 1 over 2x plus a. Our a value should be beside point A and B. In this case, the a value can be 0 since we need that it doesn't really contain a x-intercept. Secondly, in order to think about this in this way, the reason why it can't be 0 is because we know that the a value is from a dice. According to the property of dice, it can't contain 0. The number, as we are thinking about this, reminding ourselves, number in the dice should always be greater than 0. It can't be negative or 0. So, since we thought about it through the property of dice, our a value should be from the a value 4 to our b value 8. The reason why we're not counting as the y value is because if it is just same, there will only one linear function exist. Therefore, we're thinking about in the x coordinate, which is 4 to 8. This will going to be our a value. 4 to 8, which means 4, 5, 6, 7, and 8. There are totally 5 values, but the a value should only be 1. So in this case, a value can be either 5 cases. So we can apply this to our original function. We said that this a value is from the auction-drawn dice, which means the property can be 1 over 8. So it should be 1 over 8. But now we have our 5 cases, so we multiply 5. And we're going to get our total possibility answer, which we're going to be 5 over 8. 5 over 8 we're going to be possibilities of our a value. That moves our linear function y is equal to negative 1 over 2x plus a beside the point A and B. So let's review what we did here in this question. We always need to think about the ways or the things that we need to think about to approach this question. So we had 4 things. Firstly, types definition of the intercepts on coordinate plane. The most important thing here was the intercept. Secondly, we need to think about properties and definition of the auction-drawn dice. And as we can see, the auction-drawn dice were going to be 8-sided dice. So that's why we could figure out that a value can't be 0. Thirdly, we thought about possibilities of a variable from a form of regular auction dice. We got 1 over 8. Because a value should always be 1 value, and the possibility from the auction dice 8, 1 over 8. And lastly, we talked about everything about the quadratic everything about the quadratic and the linear function. So lastly, we actually apply these solutions or the things that we need to know in order to approach this question into our equation, and we got our number of possibilities of the a value 5/8.